ICMP, the Internet Control Message Protocol, is what we commonly refer to as the protocol that's used to ping things. You just saw me ping the gateway in my example a moment ago, and I used ICMP to be able to carry that ping traffic, hit that target address, and then get back that response, in 4 packets in quick succession. So we exchange control messages between hosts and gateways. We use it to diagnose, and I gave you an example of it using ping. Traceroute is also going to use ICMP. Traceroute allows us to go out and look at the hops from one machine to another, or the connections from one machine to another, all the way down the line, up to 30 of them going out, so we could see a path and look at how things are going to be laid out. And we can use this if we are not thinking about the good side of the conversation. How do I diagnose? How do I connect? How do I control things? How do I exchange information? But rather the malicious side of the conversation. How do I hack into systems? How do I get into them? How do I maybe control them and turn them to my will, right? They could be leveraged, this kind of a protocol can, for malicious behavior. In other words, we have attacks that may take advantage of ICMP when we're trying to hack into a system. And we have to think about that and keep that in mind as well. Everything that can be used for good, in theory, can be turned around and used for bad as well. We just have to understand that. Remember, as SSCPs, while we're not training you to be hackers, and we're not implying that we want you to become the hacker in order to be able to figure out how to defend, quite the opposite. Remember, we do have a code of ethics, and you're supposed to act honorably and act justly. So we're not suggesting you go out and start leading a double life. But what we are talking about here is understanding that there are bad things that can happen, and there are bad activities that can take place. And you have to be prepared, and you have to understand that those things exist in order to be able to deal with them, to defend against them, to set up our networks and manage them appropriately. You may need to understand this behavior. I'm not saying you should engage in it. I'm just pointing out you need to understand it. And so knowledge of how protocols work is going to be very important for you. One of the things that we can use ICMP to do in terms of an attack that was very popular for a long time, really not so popular anymore. You don't tend to hear about it really, but historically it's a footnote you just want to have a sense of, is something called the ping of death. Pretty cool name, right? The ping of death. So the ping of death is an enormous number of operating systems would become unstable. Again, early on, most modern operating systems have been patched for this. We no longer fall prey to this kind of an attack. You don't really need to do anything. It just doesn't happen anymore. But if we have older operating systems, and sometimes we do, running today, especially with the advent of virtualization, you may spin up something like a Windows 95 or Windows 98 machine to do something. Not quite sure what you would do with it, but you may do something, right? You might just be jonesing for a Microsoft Windows pinball game, and so you want to go out and set that thing up and use it for a while. Windows NT4, whatever it may be. If there's a reason to run some of those older operating systems, and virtualization gives us the ability to do so, you may actually have a problem with this because those may have been vulnerable to this before we re-architected the network stack to prevent this from happening. So just keep that in mind. But in modern Windows or modern non-Windows Linux Unix-based operating systems that are current and are patched, this is not an issue. This just doesn't happen. But a lot of operating systems would crash or become unstable because they would receive an ICMP echo, an ICMP ping request that was greater than the overall packet size of 65,536 bytes, effectively overwhelming the buffer that's used to be able to manage traffic, and it would render the operating system into what we call a crash state or a dump state of some kind because the system didn't know what to do with it. Oh, it's too much traffic and it wasn't told when this happens, just either ignore the packets or flush them out of the buffer or, do this, send them to the garbage can, whatever you want to think of it doing. Instead, it just sat there and said, well, I don't know what to do, and it would just stop working. So when we would send malformed ping packets against systems that were bigger than the limit, right, the imposed limit in the networking stack should be, this is what a ping of death attack was. Not really a big deal today, but historically interesting to know about. And obviously, if somebody asks a question about that at some point, you should be right there with the answer, and you'll get credit for that particular one. We may also see ICMP redirect attacks, yet another way ICMP could be used against us in terms of malicious behavior. You'll see how routers can send an ICMP redirect to a host, telling it to use a different, more effective default route. Remember, routers are going to be the gatekeeper devices, right? They're traffic management devices in our network. They sit there, and effectively every time somebody comes up and says, hey, I'd like to be able to go to 123 Circle Lane, the router looks up in its routing table where Circle Lane is, and if it knows how to get there directly, it says, okay, go right down there and make a right and, first house on the corner. Or it may say, I don't know, but I know that the guy right down the road from me here is going to be the guy who you should talk to. So I'm going to send you over to him. Go up here, make a left, and then about a mile down, stop at the next gate, i.e. gateway router, stop at the next router and talk to him. My buddy Jim is going to help you out, in other words. And, the router will send you down the road over there, right? And that's how routing works, basically. A little bit more to it than that, but that's basically the concept. And so if we're dealing with that, ICMP redirect attacks can effectively be used to send you not to Jim and not down to the right over there to 123 Circle Lane, but could be used to send you off into space. Who knows where, but to where the attacker wants you to go, which is away from the places that you want to go. And so this is what an ICMP redirect attack can do, because the attacker can send ICMP redirect information to the host telling it, hey, use my machine or use this bad machine I set up over here instead of the good stuff that the router is going to tell you how to do. We call that a redirect attack. Effectively, the attacker inserts themselves, and in such a way, and by doing that, the attacker can effectively give the host information and before the router has a chance to do that, tell you where to go, and you say, okay, well, it sounds good to me, and you go off there even though it's the wrong way to go. So a redirect attack, literally, as the name implies, moves you in a different direction based on bad or erroneous routing information, and that's what ICMP redirect attacks can do.